Warm greeting to all. This session we are going to discuss problem on knuckle joint. So these are the formulas used in the knuckle joint. So this we already discussed in the procedure how to solve the knuckle joint. So that we discussed in the previous session. So this session we are going to discuss a problem on knuckle joint. So these are the failures occur in the knuckle joint, and these are the forces used in knuckle joints. And the problem: design a knuckle joint to transmit 150 kilonewton. The design stresses may be taken as 75 megapascal in tension, 60 megapascal in shear, and 150 megapascal in compression. So the given data is P is given, that is applied load 150 kilonewton, and sigma T, that is tensile stress 75 megapascal, and shear stress tau equal to 60 megapascal, and compression stress sigma C, which is equal to 150 megapascal. So the knuckle joint designed by considering the various methods of failure as discussed below. So based on the failure equation we are going to design a knuckle joint. So step 1, the failure of solid rod in tension. So we need to find out D, that is diameter of the rod. So we know the load transmitted P, which is equal to pi by 4 d square into sigma T. So we know the value of sigma T that is given in the question, and the load that is given in the question. Substitute the values and find out the D value, that is diameter of the rod D, which is equal to 52 mm. Now various dimensions are fixed as follows. So that is empirical relationship based on D. So the diameter of the knuckle pin D1, which is equal to D, which is equal to 52 mm, that is we already found. Then outer diameter of the eye D2, which is equal to 2D, that is 2 into 52, that is 104 mm. The diameter of the knuckle pin head and collar D3, which is equal to 1.5D, that is 78 mm. The thickness of single eye or rod end T, which is equal to 1.25D, which is equal to 65 mm. A thickness of fork T1, which is equal to 0.75D, which is equal to 40 mm. Thickness of pin head T2, which is equal to 0.5D, which is equal to 26 mm. So these are the empirical relationship for knuckle joint. Then step 2, the failure of knuckle pin in shear. So the failure of knuckle pin in shear, P, which is equal to 2 into pi by 4 into D1 square into tau, which is equal to, substitute the values of D1, so that we already discussed found in previous step, and apply the load, then find out the shear stress, which is equal to 35.3 megapascal. So then step 3, failure of a single eye rod or rod end in tension. So P, which is equal to D2 minus D1 into T into sigma T. So substitute the value of D2, D1, T, P value, and find the value of sigma T, which is equal to 44.4 megapascal. So these values should be less than the given permissible shear stress, permissible tensile stress, and permissible compressive stress. Then step 4, the failure of single eye or rod end in shearing. So that is mentioned here, that is P equal to D2 minus D1 into T into tau. So substitute the value of P, D2, D1, and find out the value of tau, which is equal to 44.4 megapascal. Then step 5, failure of single eye or rod end in crushing. So load P, which is equal to D1 into T into sigma C. So substitute the value of D1, T, and P value, find the value of sigma c, which is equal to 44.4 megapascal. Then step 6, failure of fork end in tension. So load P, which is equal to D2 minus D1 into 2 into T1 into sigma T. Then substitute the values, all the values, and find out the value of sigma T, which is equal to 36 megapascal. Then step 7, failure of fork end in shear. The load P, which is equal to D2 minus D1 into 2 into T1 into tau. Substitute the values, D2, D1, P value, T1 value, then find the value of tau, which is equal to 36 megapascal. Then step 8, failure of fork end in crushing. The load P, which is equal to D1 into 2 into T1 into sigma C. Then substitute the value of D1, T1, P, and find out the value of sigma C, which is equal to 36 megapascal. So from above we see that the induced stresses are less than the given design stress, therefore the joint is safe. So your value, whatever value we found from the procedure, so that will be less than the given permissible stress, so the design is safe. Then final step, step 9, diagram of knuckle joint with the dimensions. So you have to draw the diagram and you have to mention the dimensions of the knuckle joint. So you have to mention all the dimensions with whatever we found in step 2, that you have to mention here. And so these are the design steps you have to follow while design the knuckle joint. So thank you. The remaining things we'll discuss in the next class.